Welcome back, guys. Today I'm going to work on a new sensor, that is AIS328DQTR. To gain more knowledge about this sensor, let's have a look over the website, that is controleverything.com, and here search on this for this sensor, that is AIS328DQTR. So let's see what we got here for this particular sensor, and it's a high performance ultra low power 3-axis accelerometer. As you can see, these plus minus 2, 4 and 8G are the dynamically selectable full scale range of this sensor accelerometer. Also good range of extension for the temperature, embedded self test, 16-bit output data and ROHS compliant. This is the address. As you can see, you can purchase this sensor from here. For interfacing, first of all, a Raspberry Pi and a Java code is required, which I will be interfacing today. So go to the source tab for the Java code, and here comes the Java code sample for the sensor AIS328DQTR. You can download as a zip file this code from here. You can also have the code from GitHub repository, that is Control Everything Community. Now let's have a look over the hardware connections we require to fulfill the working condition. This here is our sensor AIS328DQTR, that's a accelerometer. Now this is a Raspberry Pi, and these are the GPR pins of the Raspberry Pi. Now to make a connection among the sensor and the Raspberry Pi, we need an I2C sheet, which is available on the website controleverything.com. Now you can purchase it from there also. Now gently place the I2C shield over the GPR pins of the Raspberry Pi. Now the reason we are using this I2C shield is to make connections with other I2C devices a lot easier. Now this is a connecting cable. Make this connection among the sensor and the cable, and while making this connection, make sure that the ground terminal of the sensor should be connected to the ground wire of the cable, and similarly for the I2C shield, like this. Now we need to power up our Raspberry Pi, and here comes a micro USB cable into the picture. Now gently insert it over the power jack. So we are done with this connection. Finally, we need to make the internet connection with the Raspberry Pi and the sensor, and for that an Ethernet cable is required. As you can see, gently insert it over the Ethernet jack. In case if you don't have that, you can also use a nano Wi-Fi wireless adapter, which might come in handy, and it also might save your day. So we are done with the connections part. What we require is a code so that we can interface with the Raspberry Pi and sensor, and let's show the working. Now what do we want is a Java code so that we can interface our sensor with that using a Raspberry Pi. So for that we have to go to the website github.com, and here we have to search for the repository of controleverything.com. It's official, and it says that Control Everything Community. Now log in here, and here search for the sensor. As you can see, it's a 3-axis accelerometer. Now this is the Java code we are looking for. Well, let's have a look over the instructions first. We have to download and install Pi4j library on the Raspberry Pi, and this link pi4j.com, this is a link which will help us to install the Pi4j library step by step. As you can see, go through the entire link. It will have a relevant information being provided to you for the installation. This is the command to compile, and this is to run the Java code. Now get back to the code and let's explore it. As you can see, it's a .java extension file, and first of all we have imported some of the libraries. Now we have created a public class named AIS328DQTR. Now here the address of the sensor is 0x18. Bus.getDevice will fetch you that. Now in the writing command, we have selected control register 1 having address 0x20, and XYZ axis are enabled. Power mode is on, data rate output is 50 Hz, and the command for that is 0x27. Here it is. Now next we have selected control register 4 having address 0x23, and the command sent here is full scale range of plus minus 8G continuous update, and here Google goes for the command that is 0x30. As we are done with the writing part, now we want to read the data, and we are reading here 6 bytes of acceleration data for X, Y and Z axis. Here conversion of the data takes place according to the formulas which we have been able to fetch from the data sheet of AIS328DQTR. So we are done with the calculation and conversion part. Last, we have to display the results on the screen on the output data in the form of output data, and its acceleration in x, y and z axis. As you can see, it's perfectly formatted, raw values being displayed. So this is the Java code we want to work with. So let's have a look over that. Well, for the practicality of this code, we have to copy this entire Java code and now open up the Raspberry Pi terminal. Here create a new file, AIS328DQTR and with .java extension, and here we go, paste the entire code, save it. Now this is the command to compile it, as you can see, and here we go, the code is being compiled. Now this is the command to run the sensor, and its acceleration in x, y, z axis, as you can notice. Now when I try to rotate it, it says that acceleration in x, y and z axis is being changed. Now again, as you can see, the results are being monitored in the form of x, y, z axis in the acceleration data. So this is how the Java code works. Now what we require is to see the benefits and the applications for this sensor. The AIS328DQTR is an ultra low power, high performance 3-axis linear accelerometer with a digital serial interface SPI standard output. An I2C compatible interface is also available. The device features ultra low power operational modes that allow advanced power saving and smart sleep to wake up functions. The AIS328DQTR has dynamic user selectable full scales of ±2, 4 and 8G, and it's compatible and capable of measuring accelerations with output data rates from 0.5 Hz to 1 kHz. Now the applications are telematics and black boxes, in-dash car navigation, tilt, inclination measurement, intelligent power saving, vibration, monitoring and compensation, and a lot more. This sensor can be purchased from the website controleverything.com, and the code is available on the resource tab, and after that you can download it from this website. You can also have the opportunity to download the code from GitHub repository, and that is Control Everything Community. If you have any queries, you can contact on controleverything.com, and you can post your comments, your queries on community page. Now for articles and blogs which are relevant to this, you can contact me on instructables.com, and also to subscribe more video tutorials like this, you can have a go-through look over our YouTube channel. Now I hope you enjoyed this video and I hope you liked it. So thanks a lot for watching.